Hello, this is chapter 2.2, and this is the second part of a mini lecture on inverse matrices. So last time in the previous module, we learned that the inverse matrices are very special type of matrix. Actually, there is very few inverse matrices. Most of the matrices do not even have one. But if we are lucky and we have an inversible matrix, then multiply matrix by its inverse will always give us an identity matrix. And we can also shift the order of inverse multiplication. We multiply inverse matrix on itself or matrix on inverse, we still gonna get an identity matrix. And you're probably wondering why such a big deal about this inverse matrices. So what are the applications? There is actually thousands of applications mostly because inverse matrices will help us to solve a linear system of equation. For example, if we have a system of equation given us by the square n by n matrix A, then for any right-hand side B, we always find unique solution. And this solution can be found by just multiplying the inverse matrix A by the right-hand side. So let's just do an example just to see how that works. So let's just have simple two systems of equations with two variables, and we will write down left-hand side as a matrix and call it A. And you probably noticed that this is exactly the same matrix as we worked with in part 1 of this series, and we found it in inverse matrix. And if you're not sure how we've done it, please look at the record mini lecture for part 1 of the chapter 2.2. Okay, so now we have an inverse matrix. So as soon as we get it, we can find a solution of this equation because it's just inverse matrix by right-hand side vector B. So we write down our inverse multiplied by right-hand side vector 3, 7. And here it is. Here is our solution X. We did not eliminate anything. We didn't write anything in echelon form. And though we find a solution. But I suspect you're probably not very impressed with that because finding this inverse matrix was a lot of work. And you're probably wondering, why would you go through such a trouble if it's so much easier to solve it by elimination? I tell you why. Mostly it's because computers usually solve the systems of thousands equations with the thousands of variables, and computers are very good at finding the inverse. So when we have a large system, it just takes much less time to find the inverse than any other solution of way to solve systems of equation. So the applications are for this kind of method is enormous. In earth science, people use it. In video analysis, people use it. In biology, you name the area, somebody uses inverse matrices there. Okay, so now when we know that the inverses are useful, let's just look at their properties. And those properties probably will remind you a lot the properties of transposed matrices. For example, if we inverse matrix, we should get the matrix itself. So probably the same, remind you of the transposition. Another similar property is the inverse of the product of two matrices A and B, which will be equal the product of inverse, but it is in reverse order. Similar to transposition, we have to switch the order of matrices A and B to make their product work. Okay, so finally, if we need to take both transposition and inverse, we can do it in any order we prefer. We may first transpose and then inverse, or we might inverse and then transpose. The result will be exactly the same. Okay, there was several properties of matrices. So now I'd like you to go to the end of the chapter 2.2 and start working on exercising and start inverse two-dimensional matrices.